Okay, hi guys. So let's continue for seeing the calculation for minimum and maximum wavelength for a series. So let's get started. So we are now seeing calculation of maximum and minimum wavelength for a series. Okay. So we are doing it for hydrogen atom, and first let's get started for Lyman series. Okay, so for Lyman series we'll be using NF as 1. Okay, so first when n2 equals to, or rather n1 equals to 1, okay, and n2 equals to 2, so 1 upon lambda would be r z square is 1 only, 1 minus 1 minus 1 by 4, or rather the formula is r z square 1 upon n1 square minus 1 upon n2 square. Okay, so n1 in this case would be 1 as it is a Lyman series, then n2 is 2, hence 2 square is 4, hence 1 upon lambda is 3r by 4. When we use n2 as infinity, then wave number would be rz square is 1 minus 1 upon infinity, which would be nothing but 1 upon lambda is r, or you can say in other words lambda is 1 upon r. Okay, so in this case lambda was 4 by 3r. Okay, so lambda max would be 4 by 3r and lambda min would be 1 upon r. Okay, now let's see for the same hydrogen atom the Balmer series. Okay, so for Balmer series we have again n1 s2. So first let's look at when n2 equals to 3. So when n2 equals to 3, we have 1 upon lambda is equals to 1 rz square 1 upon n1 square, which is 1 upon 4, minus 1 upon n2 square, which is 9, hence 1 upon lambda would be r 5 upon 36, or this implies lambda is equals to 36 upon 5r. Okay, next if we see for n2 equals to infinity, then 1 upon lambda would be r 1 upon 4 minus 1 upon infinity, thus brings us r equals to 4 upon r. Hence lambda max would be 36 upon 5r and lambda min would be nothing but 4 upon r. Okay, so now let's see the same calculation for Paschen series. Okay, so for Paschen series, again for hydrogen atom we would have something like n1 again would be 3. Okay, so 1 upon, so case 1 would be, first let us see for n2 equals to 4, then 1 upon lambda equals to rz square 1 upon 9 minus 1 upon 16, this implies lambda equals to r, rather 144 upon 7r. Okay, second when we see n2 equals to infinity, okay, so lambda values would be something like r 1 upon 9 minus 1 upon infinity, that would be lambda equals to 9 upon r. Okay, so lambda max in this case would be 144 upon 7r and lambda min would be 9 upon r. Okay, next let us see for bracket series. For bracket series again the same things would be repeating themselves, that is n1 would be 4 in this case, and first case is when n2 equals to 5. Okay, so when n2 equals to 5, again 1 upon lambda would be r 1 upon 16 minus 1 upon 25, which would give us lambda as 400 upon 9r. Okay, and in second case, when n2 equals infinity, 1 upon lambda would be rz square. So z square would be again 1 upon 16 minus 1 upon infinity. This implies lambda equals to 16 upon r. Hence lambda max would be 400 upon 9r and lambda min would be 16 upon r. I hope you know that we are doing all this calculation for hydrogen atoms. Okay, so then let's actually also calculate next, which is for fund series. So for fund series, again we know that n1 would be equal to 5. Okay, and first case when we see n2 equals to 6. Okay, so for 6, again 1 upon lambda we could be r z square is again 1 upon 25 minus 1 upon 36. This implies lambda would be equal to 900 upon 11 r. Okay, so in second case, when n2 equals to infinity, 1 upon lambda would be r 1 upon 25 minus 1 upon infinity. That would give us lambda equals to 25 upon r. Okay, so lambda max in this case would be 900 upon 11 r and lambda min in this case would be 25 upon r. Okay, next let us see for Humphrey series. Okay, so for Humphrey series we would have Humphrey series n1 would be equal to 6. So first case comes out when n2 equals to 7. So 1 upon lambda would be rz square, which is 1 upon 36 minus 1 upon 49. This would give lambda as 1764 upon 13r. Okay, this would be lambda max, and then we would also be getting lambda min from n2 equals infinity. So in that case, 1 upon lambda would be 1 upon 36 minus 0. This implies lambda min would be 36 upon r. Okay, then finally just concluding that lambda max for Humphrey series would be 1764 upon 13r and lambda min would be 36 upon r. Okay, so in the next lecture we will be continuing on seeing some more insights into all these spectral series, and then so till then, good luck and goodbye.